Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Let's have a look at this past year question. Question of the year 2013, paper October-November, variance 13. For the part 1, you are asked to find the coefficient of x power 8 in the expansion of x plus 3x squared power 4. You can choose to expand this expansion and expand for every term, then only you select the x power 8 term, or you can actually just expand for a particular term. So here we go for the general term. The general formula is actually NCR, a power n minus r, and b power r. So what we need to do here, we just need to substitute what we know, the n, r, a, and the b. Like for this example, we already know what's the n, which is a 4, the a is x, the b is 3x squared. So we'll just need to sub in what we know. So instead of having NCR, we will have 4CR. The r remain as unknown. And for the a power n minus r, we can actually sub in x power 4 minus r. As for the b, is 3x squared power r. Have a look at the power here. These 4 minus r and the r. When these two powers add together, it must be equals to a 4. So which means these two powers, it can be either power x power 0, 3x squared power 4, or x power 1, 3x squared power 3. It can be 2, 2, can be 3, 1, or it can be 4, 0. So now let's check one by one. Let's say I check for the first combination, which is 4 and 0. So for now, let's substitute 4 into here. That means x power 4 and 3x squared power 0. Eventually, we will get x power 4. If you check using this combination 3 and 1, 3, substitute into here, you get x power 3. 1, you substitute into here, x power 2 power 1. So it's x power 2 times with x power 3, you will get x power 5. If let's say you substitute this combination into here, x power 2, and here x power 2 and power 2 again, 2, 2, 4, 4 plus a 2, eventually you get x power 6. If it is this combination 1 and 3, so if let's say you sub 1 into here, x power 1, 3 into here, x power 2, and power 3 again means x power 6, plus with the 1 here, then you get x power 7. So now the last one, 0, 4. So if you substitute 0 into here, you get x power 0, x power 4 here, x power 2 power 4. That means you will get x power 8. So this is the one that we want, which means the answer should be equals to 4C. The R, you leave it blank first if you are not sure. Substitute the A and the B first, and the power should be 0 and 4. So now you notice that the R is actually equals to 4. So if here you substitute the r with a 4, 4 minus 4, you will automatically get a 0. So the r here, you can sub in with a 4. And hence, 4C4 is equals to 1, x power 0 is equals to 1, 3 power 4 is equals to 81, x power 2 power 4 is x power 8. So eventually you get 81x power 8. But the question only asks for the coefficient. So the coefficient is equals to 81. Let's look at the part 2 now. Part 2, you are asked to find the coefficient of x power 8 in the expansion of x plus 3x squared power 5. For the part 2, we can use the same method as the part 1 by using the formula for a general term. So let's prepare the NCR. The N for the part 2 is a 5. So it's 5CR. R is what we are supposed to find. So I'll leave it blank. Then just substitute the A and B. The A is the same as the part 1x. The B is the same as the part 1, 3x squared. So now we need to find out these two powers here. That gives you x power 8. So let's try one by one. So let's say we'll try with 1 and 4. 1 plus 4 add up together, you get the power 5 here. Same as the power n. So if here is x power 1, here is 3x squared and power 4. X squared power 4, you get x power 8. Then plus with x power 1, you get x power 9. But we are supposed to get x power 8, which means it's not 1 and 4. So let's try the other combination. Maybe we'll try 2 and 3 here. So now x power 2 here means x squared. X power 2 power 3 will get x power 6. X power 6 plus with x power 2 will get x power 8, which is requested by the question. So this is the correct combination, 2 and 3. And for the R over here, we'll just sub in the 3. Or you can actually sub in 5C2 because 5C2 and 5C3 is the same. 5C2 is the same as 5C3 according to the formula. NCR is actually equals to NC n minus R. Okay, so for the R here, you can either follow this power or this power. You get the same value. Then you just need to press calculator to get 5C3. So 5C3 it should be equals to 10. Then x power 2, 3 power 3, you get 27. X power 2 power 3, you get x power 6. And then you get 270 x power 8. And this is the term in x power 8. But the question is asking for the coefficient of x power 8. So it should be equals to 270. This is how we do for the part 2. Have a look at the last part. Part 3. Hence, find the coefficient of x power 8 again in the expansion of 1 plus bracket x plus 3x squared and bracket power 5. When you see the word hence, means is related to the previous part. If you notice, this part x plus 3x squared is actually the same as the part 1 and part 2. So for this part, how to figure out the x power 8? Let me show you how to do for the part 3. So for the part 3, the question is 1 plus x plus 3x squared and the whole thing power 5. So how are we supposed to find out the x power 8? I'll try to show you by expanding for every term. So for the first term is 1 power 5. Second term is 5C1, 1 power 4, x plus 3x squared power 1. Then 5C2, 1 power 3, x plus 3x squared power 2. And the next term is 5C3, 1 power 2, x plus 3x squared power 3. 5C4, 1 power 1, x plus 3x squared power 4. And the last term 5C5, 1 power 0, x plus 3x squared power 5. This is how we expand for every term. And now we are supposed to look for the term in x power 8. So let's check term by term. Alright, so for the first term here, 1 power 5, there's no x power 8. So we can actually ignore this term. And for the second term here, 5c1, 1 power 4, and the x is over here, but it's just power 1. So that means x power 2 power 1, the maximum power that we can have here is just x power 2. It's impossible to get x power 8 at this term. And let's check for this term, 5c2, 1 power 3, and the x is over here. So x power 2 is the highest power, and power 2, that means the highest power that we can have is x power 4, which means for this term also we can get x power 8. Let's check for the next one. The highest power here is x power 2, power 3 means x power 6. So which means this term can be ignored as well. And here now, x power 2, power 4, we can get x power 8 here. And this one, x power 2, x and power 5, the highest power is x power 10. That means there's an x power 8 in this expansion. So let's check for this and this expansion to get the x power 8. So now have a look at this one, x plus 3x squared power 4. This one is actually what we have expanded in the part 1. Part 1's answer is over here, and for the part 1's question is here, x plus 3x squared power 4 is similar to here, x plus 3x squared power 4. So according to the part 1's answer, the x power 8 term is here, the coefficient is 81. So which means our answer should be equals to 5c4 1 power 1. I just copy back everything. And for this expansion, the x power 8 term should be 81x power 8. Actually, there are some other terms, but we are only looking for the x power 8 term, so it's not necessarily to expand for the other terms. And for the last one, 5c5 1 power 0, and look at here, x plus 3x squared power 5, which is the question, the same question as the part 2 here. So from the part 2, we already found out the coefficient for x power 8 is 270. So you can just copy back the 270 x power 8 plus the rest of the terms which are not needed. So we just need the x power 8 term. So what to do is, now you just press 5c4, which is a 5, times 1 times 81 x power 8, plus 5c5 is a 1, 1 power 0 is a 1, times 270 x power 8. So eventually you will get 675 x power 8. So the coefficient of the x power 8 here is 675. That's how we relate the part 3 to the part 1 and part 2.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.